Hi everyone, welcome back. We are continuing here in Module 2, Topic 3. We're in Activity 4. We're starting on page 311. We're going to go through 313. This will probably be a lengthier video, but we're going to get it done all in one shot. So it says you can use different methods to convert units of measure. You can set up a proportion and scale up or down to convert one unit to another. That's what we have been doing up until this time. So that's the first example. I want to kind of walk through that before I read this. So it says if 1 kilogram is approximately, remember the wavy equal sign, approximately 2.2 pounds, determine the quantity in pounds that is equivalent to 4.5 kilograms. So we know 1 kilogram is 2.2 pounds, and we're looking for 4.5 kilograms. So this shows we're scaling up from 1 to 4.5 by times 4.5. What we do to the top, we do to the bottom, so that's times 4.5. And then we end up with 9.9. I do want to just kind of point out to you here, and I think we've talked about this briefly. Notice how we're multiplying both by 4.5. So we're actually multiplying by 4.5 in the numerator and 4.5 in the denominator. And what is a fraction equal to when we have the numerator and the denominator as the same number? It's equal to 1. So we're literally multiplying by a value of 1. So we're scaling up. And because what we're doing to the top, we're doing to the bottom, we're changing these in an equivalent amount. It is truly by a value of 1, 4.5 over 4.5. They're going to refer to that here in a little bit. You can also use a method called unit analysis. To use this method, you multiply the given measurement by a form of 1 to rewrite it with different units. So a unit, when we do like a unit rate, we are doing a per 1, or a fraction bar, we say the word per and 1. We've talked about that when writing ratios. Per 1 is a unit rate. So in this unit analysis, we're always in the second part here, in the fractional part, we're going to put whatever the 1 value is in our denominator. Let me see if I can zoom in on that a little bit. So it gives us 4.5 kilograms, and it wants to know how many pounds. So they have 4.5 kilograms and 2.2 pounds per 1 kilogram. So with fractions, you multiply straight across. Okay, but what happens here? Do you see in the blue where they've crossed out the kilograms? So if I just looked at the units, we're doing kilograms over 1 times pounds over kilograms. Right? Well, when we multiply, we can make that just one great big giant fraction, right? And then we can flip these around, so we can put the kilogram here and the 1 here, and then we end up having kilograms over kilograms. So just like, I'm going to kind of do this over here, 3 over 3 equals 1, 100 over 100 equals 1, 4.5 over 4.5 equals 1, kilogram over kilogram equals 1. So these cancel out to a value of 1. And when you're multiplying something by 1, you get just the something. 1 times 5 is 5. 1 times 100 is 100. So 1 times a pound is a pound. 1 times 1 is 1. So those kilograms cancel out. They're just looking at it on the diagonal instead of doing all of this rewriting. We've been talking about canceling out like that in other things when we're reducing fractions and things like that. So that's what they're doing here. So the part that they want it to go to, pounds, is going in the numerator. So then they're using the conversion rate that we know of, 1 kilogram. 1 kilogram is 2.2 pounds. And they're putting it so that the pounds is in the numerator, because we want the kilograms to cancel out. And then notice they're just multiplying straight across. So, and we talked about in class we're going from kilograms to pounds. So a kilogram is bigger than a pound. So remember, we did in class, you're going from something bigger to smaller, and it crosses. We showed that in class where you held out your hands a given distance. All right, my hands, and we're going bigger to smaller. So we're multiplying. I'll kind of work that out in class and show you guys that again. So we're multiplying straight across and we get the 9.9. Okay, so let's go down here and look at an example then. It says, analyze the worked examples. Both strategies used a form of 1 to determine the equivalent number of pounds and 4.5 kilograms, 4 and 5 times kilograms. How is the form of 1 used in scaling up different from the form of 1 used in unit analysis? So in scaling up, the form of 1 is shown as 4.5 over 4.5. Okay. In unit analysis, so that's this second way. So since 2.2 is approximately 1 kilogram, multiplying by the conversion ratio is the same as multiplying by 1. I just abbreviated it there because we had that kilogram here and we had the kilogram here, and this here being our 1. Let's see if I can get this lighting a little better. Actually, I think that's better. Okay. Seems kind of dark in here to me, but it looks better on the screen. So we have the kilogram over the kilogram. Those cancel out. So that is the conversion of 1. Why do you cross out the labels for kilograms? So a kilogram over 1 times a pound over a kilogram means kilogram over kilogram times pound over 1. And then this equals 1. And we're left with this. And that is the unit we want it to be in, pounds. Okay, pause as you need. I'm going to move on. A marathon is a long-distance foot race with an official distance of 42 and 195 thousandths kilometers, which is 26 miles and 385 yards. Christopher and Max want to determine the number of miles in 5 kilometers using unit analysis. So unit analysis. So let's see who's right. It says Christopher's wrong. He did 5 kilometers or kilometers, however you say it's okay, times 1.6 kilometers per 1 mile, which is the correct conversion rate. 1 mile does equal 1.61 kilometers. And he says 8.05 miles. Max says 5 kilometers times, he did the miles in the numerator and the kilometers in the denominator, and he gets approximately 3.11 miles. And it asks, why is Christopher's answer not reasonable? So he's starting with 5 kilometers, and then he says it's 8.05 miles. So why is that not reasonable? Well, remember we said if we know that's the conversion rate, if that's a mile, 1.61 is almost 2 kilometers to be the 1 mile. So miles are longer than kilometers, so it should take fewer miles to equal a greater number of kilometers. So that just doesn't make sense. So we're going to say miles are longer than kilometers. So it should take fewer miles to equal a greater number of kilometers. Number 3, explain what is different in how Christopher and Max set up their multiplication problem. What is important about how they arrange the units and the conversions. So Max set his up so that the unit he was converting to was in the numerator, and what he was starting with was in the denominator, because he knew he needed to cancel out the kilometers. And Christopher didn't do that. He did kilometers times kilometers. So he would have really gotten square kilometers per 1 mile. So that just doesn't even make sense. Okay, so Max set his up so the unit he started with, which was kilometers, was in the denominator. Because he wanted those to be able to cancel out to 1. And what he was converting to was in the numerator. Okay, and pause as you need to. I'm going to move on. Number 4, there are many other distances in which runners can train to race. Complete the table shown by writing the unknown measures. Now some of these we can kind of fill out here. So we know 1 mile is about 1.61 kilometers. So they tell us that 5 kilometers is about 3.1 miles. These are all abouts. So everything's like a little squiggly line. So some of them may be a little bit different. But if we just use the table here, we could fill these out pretty easily. So if we double 5, we get to 10. So if we double this, we're going to be at about 6.2. And then if we did a times 4, actually here, let's just go here, times 2. So if we do times 2 here, we're at like 12.4. Okay, so then what about the 100? So if we did 10 to 100, we're doing a times 10. So we're going to be at about 62. If we use the conversion method, we're going to get a little bit higher than that, and I'm going to show you that. Okay, so the half marathon, we know miles, we're looking for kilometers. So I'm actually going to write it here on a different piece of paper, and in class I'm going to suggest that you guys do the same thing too. So we're starting with miles. So Max set his up so that the unit he started with was in the denominator, okay, of the other side. So we're starting with 13 miles. So what we're multiplying it by, he's going to put in the denominator. So 1 mile is 1.61 kilometers. Okay, and then this is over 1. This becomes miles over miles, which cancels out, and now we're just going to multiply straight across. And when you multiply 13 times 1.61, I don't know where my calculator went. I literally don't. Well, if we multiplied that straight across, you're going to get 21.091. I need to pause, find it, and I'll be right back. You won't even know I'm gone. Okay, here we go. Alright, so sorry about that's the light on the document camera, but it's okay, because what you need to see is down here. So 13 times 1.61 is 20.93. Where did I get the other number? I guess it is 20.93. I am not sure where I got this other number here. We will pretend I didn't even do that. I do not want to start this video all over, and I can't go back and record over, so you get what you get. I'm not sure why. I have had so many errors in my book, like the one we had yesterday, with the longer and shorter, the yards and the meters. Anyway, we're going to move on. Okay, so if we did let me see here. Oh, wait. I'm sorry, it's 13.1. I do know what I'm doing. It is 13.1, not just 13. So that little 1/10 makes a difference. It is 21.091. I just want to fill it back in on the table, and I'm looking at this number, and it's not just 13, it's 13 and 1/10, so it is 21.091. Okay, so if we did the 100, I'm going to show you how it turns out a little bit differently. So we know the kilometers. So we know 100 kilometers. So if we put the kilometers in the denominator so that they cancel out, 1 mile is 1.61 kilometers. Those will cancel out. Now we have 100 over miles over 1.61. So then we're dividing. So we're going to do 100 divided by 1.61, and we get 62.11. So you can see that it is just slightly different, which is okay because these are estimates anyways. Okay, miles, 2 4/10 miles. So we're doing 2 4/10 miles. So using unit analysis, if we're going to put the miles, we have the miles here, and we're going to the kilometers. What we're going to convert to is going to go here. Miles will be here, so 1 is here, 1.61. Now we're just going to multiply straight across. So we have 2.4 times 1.61, and we get 3.864. So 3.864, which seems right. 3.1 miles is 5 kilometers, so this is a little bit less. It makes sense that this is less. Okay, 112 miles. Hopefully you're getting the hang of this. We're starting with miles. So we want to convert to kilometers. We put what we want to convert to in the top. Multiply straight across. 112 times 1.61, 180.32. The miles cancel out, and we have kilometers. 112 times 1.61, 180.32. I'm going to pick one of these and show you scaling up works as well. So for example, if we had, let's just use lower numbers. Let's say we did the 2.4 miles. If we kept miles here, and 1.61 here. How are we going? We need to go this way. So how are we going from 1 to 2.4? We are multiplying by 2.4. So down here we'd be multiplying by 2.4, which is essentially what we did here. We still did 2.4 times 1.61. So it gets you the same thing. So our ratio here would still be 3.864. So when we do it this way, we're showing ratios, 2.4 miles for every 3.864 kilometers. We're not dividing this. This is showing a ratio in fractional form. We're not actually dividing that. We're scaling up going this way. Okay, moving on. On to page 313. Conversion rates are also common in other countries. Conversion rates are also common in other contexts, like currency, which is in other countries. During one summer, the currency exchange rate between the US dollar and the Brazilian real was $1 for every 3.17 Brazilian reals. Alejandra's family went on a trip that summer, and she budgeted $500 to spend while she was gone. Rate the conversion rate. So we have $1 US for every 3.17 Brazilian reals. Did Alejandra budget more or less than 500 Brazilian reals? So if she did 500 US dollars, is this number going to be 500 Brazilian real or more than that? Right, it'll be more. There are a little more than 3 Brazilian reals for every 1 US dollar. So $500 would convert to more than 500. Actually, I guess we don't want a dollar sign. We want 500 Brazilian reals. So how many Brazilian reals could she spend in Rio de Janeiro? So we are wanting our final answer to be in Brazilian reals. I'm going to do it both ways, both with scaling up and then with unit analysis. So if we scale up, if we are starting with $1 for every 3.17, and we're going up to $500, what do we have here? So we're doing a 1 times 500. So we're going to do a 3.17 times 500. So we're doing times 500 times 500. And remember, that's our like version of 1 there. So 3.17 times 500 is 1,585 Brazilian reals. So now let's set it up with unit analysis. So what we're starting with is going to go first. So we're starting with $500 in US, and we're converting it to the Brazilian real. So that'll go in our numerator, what we want to convert it to, and our dollars is going to be down here. So 3.17 Brazilian reals for every 1 US dollar. So here our dollar signs cancel out, and we still have the 500 times 3.17. It's essentially the same thing that we did here. So you're still going to get 1,585 Brazilian reals. After Rio de Janeiro, Alejandra's family traveled to Mexico, where 1 Brazilian real was equal to 5 and 92 hundredths pesos. If Alejandra if Alejandra had 295 Brazilian reals remaining, how many pesos did she have? So let's see. If she had, I'm going to do both ways again. If she had 1 Brazilian real for every 5.92 pesos, and she had 295 Brazilian reals left, how do we go from 1 to 295? We do times 295, do that down here, times 295. So 5.92 times 295. $1,746.4 pesos. Unit analysis. So we know we want to turn it to pesos. We know she's starting with 295 of the Brazilian money. We know the exchange rate is, what did we say, 1 Brazilian real for 5.92 pesos. So you multiply straight across, but our Brazilian reals cancel out. Again, we have 295 times 5.92, which is exactly what we had here. We are still going to get the 1,746.4 pesos. Number 6, Emma is preparing to recarpet her room. She measured the room to be 6 yards long and 8 yards wide. When she got to the carpet store, all the measurements were in square feet. Determine how many square yards of carpet Emma needs to buy to recarpet her room. Okay, so first they're asking us to do it in yards. So we know her room is 6 yards by 8 yards. So that gives us 48 square yards. Determine how many square feet Emma needs to buy to recarpet her room. So how many feet are in 6 yards? Well, how many feet are in 1 yard? So we know there's 3 feet in 1 yard. So how many feet will there be in 6 yards? So we would have to do a times 6. So 3 times 6 gives us 18. So if we're doing a times 3, 8 times 3 is 24. So in feet, her room is 18 feet by 24 feet. And when you multiply that together, you get 432 square feet. Okay, and I think I'm just going to do a couple of these. I think we're going to keep it going here. I want to hop right down here. When you convert a measurement with smaller units to a measurement with larger units, does the number of units increase or decrease? So when you're going from a measurement with smaller units to a measurement with larger, so then the number of units decreases. So for example, if we have 12 inches and 1 foot, we're going from a smaller unit to a larger unit, the number of units decreases. So when we go from a larger unit, like 1 foot, to a smaller unit, like inches, the number of units increases. Okay, complete each conversion. 12 gallons is approximately how many liters? I'm not going to take time to go back and flip through the book to show you where the conversion is. I'm going to tell you the conversion units here. I will tell you that 1 gallon is 3.79 liters. 1 gallon is about 3.79 liters. And let's see, here we need to know 1 pound is 16 ounces. And here we need to know, we have inches and yards. 1 yard is 36 inches. Here we need to know between kilometers and meters. We need to know that there's 1,000 meters in every 1 kilometer. Okay, so when we set this up, we have 12 gallons, and we're going to liters, so we're going to put our liters here, and our 1 gallon here, so 3.79, and when we multiply straight across, we get 12 times 3.79, which is 45.58 liters. Number 5, 240 ounces, and we're going to pounds, so we're starting with the 240 ounces. We're going to pounds. So we have 16 ounces in 1 pound. So then these cancel out just like that did here. So we have 240 divided by 16, which gives us 15 pounds. We're starting with 3.80 kilometers. We want to go to meters. We know that there are 1,000 meters in 1 kilometer. When you multiply straight across, we get 380 kilometers cancel out. So we get 380 meters. And last one, 324 inches. And we're converting it to yards. So our inches go down here so that they can cancel out. So we have 36 inches, 1 yard. So we're going to do 324 divided by 36, which when you do that division, it equals 9 yards. Okay, I know I went really super fast on that, so go back, pause, rewatch as you need to, and we'll see you back in class.